All right, who first up? Aiden, give me some details that you saw on this diagram, please. See the moon. Oh, okay. All right. There is the moon. I didn't even see that. But there it is. Thank you, Aiden. What else? Sun. What else, Aiden? Earth. Nice. Keep going. What else do you see? What's that? Heat waves. Yes. You have a bunch of different types of incoming solar radiation. Heat coming into the earth. But, Aiden, does all of it get into the earth? No. What happens to some of it, Aiden? Like right here. This first one. Boom. You get, and this one. Boom. What happens to some of the heat? Reflects. So reflected back to space. Some of that heat gets bounced back out. Okay? Oh, all the headphones need to be out, Rodrigo. That's why you're dancing around so much. Yeah. Rodrigo, what else is happening there? What else? What other details can you add to Aiden's list? Yeah, we had that. Oh, good. There are greenhouse gases. What are some examples of greenhouse gases? It's not a greenhouse gas, but one has oxygen in it and then something in front of the oxygen. That's not a gas. But photosynthesis needs this gas to operate. Carbon dioxide, see? Carbon dioxide, that's the main greenhouse gas that we're worried about. Okay, so greenhouse gas is mainly the one we're concerned is CO2. And very important, Rodrigo, some of that energy is re-radiated back to surface. So I want you to write that down. Re-radiated back to surface. And then circle that, because that is really the problem. We're having too much of this. Everything else is acting normally, but there's too much of the re-radiation because there's too much CO2. There's more than we want. So that's what's making it hotter on Earth, driving a lot of climate change effects, driving a lot of weather events, big hurricanes, big tornadoes, big stuff. Okay, global warming. Okay, from this right here. Re-radiated back, re-radiated. It's not leaving, it's got to leave. Have you ever had somebody came to your house and didn't want to leave? You want them to leave? Yeah? No? You have a party and people aren't leaving? That ever happened to you? Okay. So yeah, this heat's not leaving. We want it to, but it's hanging around too long. It's messing up our Earth, messing up our dynamics here. Okay, the second question. So that was all those things you can look at on the second page. What could happen if our cloud cover increased? What possibly could be the result of that? Deuce, what'd you put? Whoa, no cursing, Deuce. Did you put S-H-I-T on your paper? Okay. So what could happen, Deuce, if we have thick cloud covers? Thicker cloud coverage in the atmosphere, say right here. How could that affect us? The energy from the sun, that is. Well, clouds can make rain, but let's think in terms of energy from the sun. Like, what do you see happening physically here? What are the clouds doing? What could they do? When you're outside and it's sunny and then the clouds come in, how do you feel, Deuce? Hot. You feel hotter, don't you? And if it's a cloudy day and the sun comes out, yeah, you feel hotter. So could they possibly reduce the temperature on the surface? Yeah, so it could reduce surface temperatures. Because you're blocking rays from the sun. Okay, so that probably makes sense to you, right? If you block the sun, you don't get as hot. It's very hot when, well, you get hot when the sun is shining right on you. Now, Manny, is there another possibility? Could the opposite happen? Could it get hotter? Could the clouds do this? Potentially. Yeah, they could. So they could actually trap heat and make it warmer. They could, yeah, make more humid, increase surface temperature. So increase surface temperature by trapping heat. Okay, both can happen when we increase cloud cover. Typically, it's clouds that are higher can make it cooler, and clouds that are lower can make it warmer. So it depends on where the clouds are and other dynamics, weather dynamics. Weather's complicated, right, Jeremiah? It's not just cut and dry, total simple. There's a lot of things going on when we look at our weather. Okay? All right, so make sure you have those notes down there. Today is our last day to do work on our posters. Okay? So we want to have, by the end of the day, our posters finished. So let's take a look. Let's take a look. The things that I've noticed. Remember, the Bohr model, that needs to be key. You have the nucleus and then the rings around it, right? With the bumps, the little dots for the elements. Make sure you're not forgetting the excited diagram, the excited electrons. So we drew diagrams of this on the lab sheet you can look at. You got to draw an arrow showing where the electron moves up, Marcus. When you add energy, when you put it to the flame, and then it falls back down. It goes back to its ground state. So it gets excited, it rises up, and then it gets unexcited and it falls down. When it falls down, that's when the color is released. So let's use blue. Say this is the Chucky one. That's when light comes out. Okay? Rises with energy. When it falls, that's what creates the light. These lights are giving us light because electrons are falling electrons. So I don't want you to call those lights. I want you to call that falling electrons. Okay? What is this? Falling electrons. If it's too dark, what do you want to say to me? Can we turn on the falling electrons? If it's too bright in here, you want to tell me to do what? Turn off the falling electrons. We want less falling electrons so we can see what we're tracing, or so we can sleep. Okay, so falling electrons, that needs to be, oh, Joseph, you got gum? Get that in there. That needs to be obvious. Okay, and don't forget your real world connections. how, and do a couple, 2 or 3. Just don't draw a little diagram. Explain what's happening. Okay? A what? A water? Oh, I don't have any. Okay. All right. Oh, by the end of, or at the end of after today, there is a exit slip for you to fill out on Canvas where you'll describe what you did during your group work period. Okay? All right. Any questions? So if you were here and you started the poster, go grab your poster, get in your group, and get started. If you were not here, you're not in a group, just sit tight and we'll figure it out. Let's go. Oh, excuse me.